Hello Chem 1. Last time we were together we talked about double replacement reactions, which is when two compounds react with one another. Today we're going to take a look at taking double replacement reactions a step farther and look at the net ionic equations that go with those double replacement reactions. Let's get started. When we talked about double replacement reactions, we showed that there usually is one precipitate or one product, and then there's another compound that is still dissolved in an aqueous solution. A net ionic equation just focuses on the product that is produced, so a precipitate or a gas. Ions that bond together but stay dissolved in the aqueous solution we call spectator ions, and they're not involved in the product. They are typically identical on both sides of the equation. If they're aqueous on the left, they'll be aqueous on the right. The net ionic equation are the ions that are left after the spectator ions are removed. Let's do an example. So with this equation we have solutions of barium chloride and potassium sulfate. Let's write out our reactants. And remember, anytime you're making ionic compounds to balance the charges, and this would be barium chloride and potassium sulfate. Now we're going to switch the barium cation and bond it to the anion of this one, and the potassium anion is going to bond to the anion chloride. At this point we need to look up KCl and barium sulfate to see which one is a precipitate. You might remember that potassium, because it's in the first column, will always dissolve. That makes this KCl AQ. And if we look up on the chart, barium sulfate will actually not dissolve. It is not soluble and therefore will be a solid. It is our precipitate. So the next thing we want to do is think about the ions involved in this equation. Net ionic equations want us to remove any ion that does not change. So a safe assumption to make is that any ion that is in the precipitate, we know that that changed because it was aqueous on the left and it is currently solid. So a net ionic equation will always end with the product, which will be the precipitate. The next part of this net ionic is to include the ions on the reactant side that will make up this precipitate. So we have barium, which is a +2 and aqueous. And we have sulfate, which is a -2 and aqueous. This is a net ionic equation, so you're supposed to be showing these as ions, which is why we include the charge. Let's try another one. The first thing you have to do is write out the double replacement. We know this cesium nitrate, because it's a nitrate, will be aqueous, which means the silver bromide will be our precipitate. This is already balanced. So for the net ionic, we have to start with knowing that the precipitate, or the true product, is what we're looking at. So that would be the silver bromide. Now, on the reactant side, we need to show the reactants, the ions that are going to produce that product. So silver, which is a +1, and it was aqueous, and bromine, which is a -1, and is aqueous. And that's a net ionic equation. It's literally just taking the ions of the reactants and showing how they're going to produce the product that we're actually looking for, while removing the spectator ions. Work through the activity, practice these, and let me know if you have any questions. We'll see you soon.